Hello everyone, welcome back to another video. So in this video, we are going to see about one interesting DevOps project named KubeSecureCheck. So about KubeSecureCheck, as we know that Kubernetes becoming the go-to platform for container orchestration. So you might be having you might be deploying microservices-based application, container-based application on Kubernetes. That has become the go-to platform, right? So Kubernetes, by nature, it is really a powerful container orchestration tool, but that comes with a lot of security loopholes also. So if unattended, that will lead to like a lot of problems. So for that, we have come up with a project called KubeSecureCheck. So about KubeSecureCheck, so it's kind of an automated security scanning and reporting solution for Kubernetes cluster. So in this project, like what we're trying to do is uh, we have identified and selected a couple of security tools which are already available in the market, couple of open source security tools which are available in the market. So using those tools to scan your clusters and get to know about the vulnerabilities and security loopholes you have in your Kubernetes cluster. So you're trying to get those already available security tools, scanning your cluster with those security tools, and trying to get those results and trying to visualize those results from any reporting tool. So here in our case, we have selected one reporting tool. So this is about this project. So some of the features about this project. So we will see that, more about this, like what are the different security tools we have used here and for what purpose and why that has been selected and which area of security like it is going to cover. So when you talk about like Kubernetes, there are like a lot of security areas which you need to cover. So kind of like 360 degree you need to cover. So and also like when you take like Kubernetes, like a lot of areas like which you need to take care of on your own. So if you're infra engineer, like DevOps engineer, platform engineer, uh, so there are like a lot of small things like you need to take care, like in terms of scaling, in terms of availability, security, storage, and a lot of things. So security being the uh, topmost priority. If unattended, that will lead to like business loss, reputation, and a lot of other things, right? So let's get started. Okay. So some of the key features about this project. Okay. So automated security scanning, as I said, like some of we have like identified like some of the security tools which are available in the market. So like kube-bench, kube-audit, Trivy, and polaris. So we will see in detail, about each of these tools in the coming slide. And then like what are we trying to do? So we are using these tools and scanning your cluster for any vulnerabilities or any security issues and trying to export those results as CSV. And we are storing those results, CSV results in some object storage. So for the purpose, we are taking like MinIO. And then we are using Grafana dashboard for visualization purpose. So that, the multiple people can visualize from the same place and you can do some transformation, full transformation. And to make this completely automated, we have used GitHub Actions pipeline. You can use it one pipeline. Okay. First of all, let's start with like what are the security tools we have used here. So Trivy, so starting with Trivy. So Trivy is capable of doing uh, capable of scanning different areas of security also, but here we have used for specific purpose to scan your image vulnerabilities. As I said that when you consider like Kubernetes cluster, it's not that you deploy your application alone, right? So you will create one Docker image for your application, basically. Okay, you don't deploy that alone. So basically, you get to deploy a lot of other important components that will be like useful for your application. So in terms of like monitoring, in terms of logging, secret management, like Istio, service mesh, Argo rollouts, for deployments, right? There are like a lot of platform components you'll be deploying in the cluster, so that it will be useful for your application in terms of monitoring, scaling, for availability, and for a lot of other purposes. So, so like those components, those could be like official images. Those could be some open source projects. Could be like any image, right? So like Trivy will help us to scan those images find any vulnerabilities. Okay, so whether you have like any vulnerabilities which needs to be taken. Okay, so next security tool is kube-bench. So kube-bench will help us to provide CAS benchmark results. So I will talk about that. You know what is that benchmark and what is CAS is all about. So it will try to provide these benchmark results. So CAS and there are like a couple of global organizations which provides security standards. So you can simply like adhere to those security standards. You know you can check your Kubernetes cluster and see like whether your infra is adhering to those global security standards that we are, whether you are like compliant to those standards, like that, those kind of benchmarks, it is able to provide. Cube, kube-audit is able to scan your Kubernetes cluster for general security audit. Okay, so we'll talk about that. And Polaris is another security tool. It's able to provide best security practices, in terms of security, reliability, as well as efficiency. It is able to provide some advices and recommendations. Okay. So before getting into this, so we need to understand like what is the need for Kubernetes security first of all. Okay. So as I said that it's a very powerful container orchestration platform, but it comes with like a lot of security risk. Okay. So that can compromise your application workloads and that leads to like business loss, reputation, and a lot of other issues. Okay. If unattended and not managed properly. So what are the different security challenges we see in Kubernetes? So a lot of misconfigurations. You might be dealing with a lot of Kubernetes YAML files, and there could be like a lot of misconfigurations happening there. Unauthorized access. So you might be dealing with root access, all these, privileged access, that needs to be like taken care. And container vulnerabilities, as I was talking about, a lot of platform components will be deploying and a lot of open source images, if not like official images, will be using. So whether those images are actually like good and without any vulnerabilities, or whether any ransomware, kind of things getting installed in it in front of. So all these things, needs to be scanned. And data exposure. So you'll be mounting storages. So whether what kind of access you're providing, like read access, write access. So all these things needs to be monitored. And network threat. So obviously, right, that could be a lot of incoming and outgoing traffic, and that could be like a lot of network ingress and egress. Network ingress and egress kind of configurations we'll be dealing with. So all these things, these basically like security challenges in Kubernetes. So all these needs to be like has to be attended. If not attended, that will leads to like a lot of problems. Okay. So what are we trying and why this needs to be like automated and needs to be taken care? So for consistency. So if you're able to like scan your cluster for vulnerabilities continuously, you will get to know like, okay, this is the vulnerabilities and these are the remediations like I have done and these many got reduced. So for the consistent purpose, that is really good to get to know like how secure your Kubernetes cluster and early detection. So instead of getting into production and get to know the vulnerabilities, like you can scan for early detection and you can solve this problems. And for complaints purpose, okay, so there are like sometimes that could be like you need to be like compliant to certain security standards and best practices, right? That could be the expectation from the client also sometimes. So need to be compliant. And for improved visibility, so these results can be shown using some reporting tool and reporting solution so that everybody can visualize from a common place and you can do some cool transformation out of it. So this KubeSecureCheck, tries to address these and try to automate these and report these and effectively. So let's get into the architecture, like how are we going to pull these? So in this, as I said that we have identified like four different security tools. So what I have done is like we have created a Docker image out of it. So we have created a pre-built Docker image out of it, and then like we are pushing to your favorite Docker registry. So for my purpose, like we are pushing to our Docker registry. So that's not the point here. So you can push it to your whichever Docker registry you are using, like Docker Hub or ECR or anything. Okay. And then like what are we trying to do here is for the automated purpose, we are using like GitHub Actions pipeline. Okay. using the GitHub action pipeline, and so you're going to run your GitHub action workflow in a containerized workflow. So as you know that people who are using like GitHub actions, so you can simply call the runner and you can install these security tools, and then you can scan your cluster using this security tool, like using CLA commands. Like you can call like each of these security tool and you can scan your cluster. So instead, what we are doing, we have created a Docker file, like a Docker image with all these security tools, and then we are running our GitHub Actions workflows, and then like calling each of the security tool and scanning our cluster for any vulnerabilities. So each will be able to provide like distinct security scanning results. Okay, that is why we have identified uh, four different tools which is like able to cover different areas of Kubernetes security. And what we're trying to do is, after getting the results, we are combining the results, and then the result is finally saved as CSV. So that is visualized in Grafana. Okay. The CSV is visualized in Grafana. So for that purpose, it needs to be stored in a centralized place in a kind of S3 object storage needs to be stored. So for that purpose, like we have used like MinIO. So MinIO is similar to Amazon S3. You can use like Amazon S3 also. So and then like in Grafana, there is a data source called Infinity Data Source, and using that data source, we are feeding the CSV as input to the data source, and like we are able to visualize these results in Grafana. So as you can see, this is kind of my idea, and the kind of tools we have used. It's up to you actually. So instead of like GitHub Actions, like you can use your CI pipeline, like Jenkins or whichever CI tool you're using. Instead of like MinIO, you can use like Amazon S3 or something like and then like for Grafana for reporting solution, you can use Power BI or different reporting tool also for visualization purpose. So it's all about your idea. Okay, and then let's see about each of these tools. Cover each of these tools. Okay, so starting with Trivy, so it's a product of Aquas. As I said that we are not creating like any security tools. Like we are making use of the security tools which are already available in the market. These are like open source security tools. So Trivy is capable of doing like multiple things. So one among that important thing is like it's able to scan like container images. So as I said that we are using like a lot of container images. Like it is able to scan the container images and try to find the vulnerability. So yeah, scan or misconfiguration, and it supports like multiple. So these are some of the examples uh, is able to provide high, medium, and then which package like you're having vulnerability. So all these results it is able to provide. So kube-bench, as I said that it's able to provide CS benchmarking results. So CS, as I said that it's a global organization which defines security standards. Security for internet security means like internet security standards. So best practices, and it's kind of provides like standardizations. So instead of you invent something and adhering to that, you can follow. There is a global organization which are providing benchmarks. You can scan your cluster and see that whether you are like adhering and complying to those security standards defined by the global organization. And there are like other organizations also like NIST, like National Institute for Security. They provide like some standardizations also for internet security. So you can simply scan your cluster and see that whether you are meeting those standards, meeting those benchmarks. So this is like really important. Sometimes client will be asking like whether you are using any benchmarks, whether you are like compliant to those benchmarks. All these things are like really important. So you can see here like some of the examples like on whether your API server has more permissions or restrictive permissions, what kind of whether you're provided like root permission, what kind of privileges you're providing. So all these it is able to provide. And kube-audit, as you said that it's a general security audit for your Kubernetes cluster. Okay, so it's another tool. So it is able to scan and tell you that whether you have used provide a root access, any open privileges, like whether you have stored any sensitive information in config maps, it is able to scan for any pod security policies, network policies also, right? There is like network ingress and egress policies. So all these, it is able to scan and provide you, the recommendations. And finally, like Polaris. So it is another security tool. Um, it is also able to provide some distinct results. So it not only provides best practices for Kubernetes security, it also provides some reliability and efficiency related recommendations also. For example, that, missing CPU request. Okay. So that will be like helpful for reliability purpose, and like your image, does not use a pinned version, basically that's official version, like a stable version. Okay. So something like that, it is able to provide like in terms of like API, like whether you're using like deprecated or like uh, so those kind of scanning results it is able to provide in terms of like efficiency and reliability also it is able to cover. Okay. Yeah. So let's see like yeah. So this is our GitHub action pipeline. Um, Basically, here what we are trying to do is, as I said, that you can use your own CA tool also. So for my purpose, like I've used GitHub Actions pipeline. So here, like we are doing it simple. Okay, so we have already created pre-built image, and that is like pushed to Docker registry, and in our GitHub Actions pipeline. So we have like 4 different jobs for each of the security tool. You can see here under jobs, like we have Polaris scan and kube-audit, Trivy, and then like kube-bench scan. So what are we trying to do? So we are calling. So basically, uh, we are calling that Docker image. Using that container, we are trying to run our workflow, right? We're calling like each of the security tool, and then like using each security tool and using like CLA command. Okay, so we are scanning our Kubernetes cluster and trying to get the output. So for example, if we take the Polaris, so like using CLI, we are scanning our cluster and then like storing the results in YAML file. So basically, like end of the day, like we are trying to combine the results in a CSV so that that can be visualized well in Grafana. So although like we are getting the results in YAML, like finally like using some Python script, like we are trying to convert those results in CSV. Okay, so that is what like we are doing for each the security tool. So we are simply like calling the security tool and passing CLI commands and getting the results in either JSON, YAML, or like whichever output format that security tool is providing, and then like finally getting the CSV. So how are we connecting to the cluster? So using kubeconfig file. Okay, so kubeconfig is stored in GitHub secret. So and then like we are getting that to connect to authenticate to the Kubernetes cluster. Okay. So here, one interesting thing is like, we are not installing anything inside the cluster, not implementing anything inside the cluster. We are running like everything, we're keeping it everything outside of the cluster so that, you know, you will have some confidence, right? Because when you are running like inside of your cluster, so it might change the state of the cluster so that you might not like it, okay? Our team might not like it. So it's going to change the state of the cluster in production. People don't like it. So they're like trying to, so we have identified tools based on that. So we're trying to scan our cluster like outside using the CLI commands and then like finally getting the result. So that's how it is. So Trivy scan and kube-bench and then so finally like we are combining the results and finally like getting the CSV out of it. And then, as I said, that MinIO for object storage, you can see here, the results are stored as a CSV. So there are like JSON results. So basically, like the CSV results. Okay. So if I have to open like one of the result, so this is like one of the results for kube-bench. Okay. So this is like converted to CSV, right? So like that, we have stored all the files. So when you look at the architecture, so when we get the CSV and we are like uploading to the MinIO, so at this moment, like it is not automated. So from GitHub Actions, it needs to be like automatically saved and or like uploaded to the object storage. So this part is not automated at the moment. Like downloaded the files from GitHub Actions artifact and then like uploaded to MinIO manually. Okay, so this can be like automated, like very simple. So we have the final findings of CSV and object storage, and this is the expected result. So here, what I've done, so as you know that people working in Grafana, so we have created a dashboard, simple dashboard, and then like I have created dashboard like KubeSecureCheck, and these are the results. So basically, like what I've done, I've created like 4 different panels for each of the outputs for each of the security tools. So how are we providing that CSV as input to infinity data source of Grafana? Something that go to edit and see. There is a data source called infinity. So I've named it as KubeSecureCheck. So you can see I've selected CSV, backend, and then the URL. So the URL is something that the MinIO object storage URL. Basically, it's running in MinIO. My object storage is running in local. Uh, so we have pointed to that basically. So you have like a couple of other options also, like you can provide the inline. So basically the raw CSV output, you can provide that as inline, or you can store these outputs in Azure Blob or the URL itself. Like if you store in Amazon S3, you can provide that S3 endpoint also. So if you look at the results, yeah. So this is like Trivy results. As I said that, it's able to find container image vulnerabilities. You can see there are like a lot of vulnerabilities it has found in my cluster. So we have installed like Thanos and a lot of platform components are running. So you can see it is able to provide the vulnerability ID and it is able to provide the severity of, high critical. So basically I filter out high critical only, like I have skipped warnings. So you can see like what is the message? So basically, like the detail of the vulnerability, right? And one good thing is like, it is able to identify like what is the installed version, what is the fixed version, like how you can fix it. So with this, like, you can basically like fix it. Second thing is like kube-bench, as I said that, it is able to provide CS benchmark results. So it has scanned, lot of security in terms of like kubelet, whether you are using like read-only, root permissions, and, like it is able to like the cluster admin role is used when required. Like you can see like it provides warning. So whether you are meeting those standards, so it provides status like pass, fail, and warning. Okay. So at the moment, like, I've scanned my Kubernetes cluster node, not the master. So yeah, it's up to you. Like when you're passing CLA command, you can choose like node or master. So with that way, like, we'll be able to like get results for master as well as node. And the kube-audit, she said that, it's able to scan your cluster for general security audits. Okay. So there are like a lot of namespaces we have, like it is able to scan and provide, like you can see like another message, read only file system is not set in container. Okay. And then like there is like annotation missing. Okay. So limits not set, allowed privilege. So there are like a lot of audits it has done. So it is able to provide like error warning and it's able to like differentiate. And so it is able to like scan like everything, all the namespaces, all the platform components, all the components basically is able to scan. And finally, like Polaris for security best practices, as I said that it not only scans for security, it also scans for reliability and efficiency. Like you can see like the CPU limits, the memory limits, the image pull policy should be always okay. So these are some of the recommendations, and it's able to scan like all of the security tools, like, and it is able to provide like warning, danger, and based on the severity score also. So this is basically the idea of this DevOps project. So like hope this is useful. Like this can be like modified and altered like according to your use case also. So if there are like other security tools also like available in the market, and you can choose the security tools. And so the idea is really simple. Like we have taken like some of the highly reliable security tools available in the market, and we have identified like Kubernetes security areas which needs to be like scanned. Okay, so we are using these security tools in an automated way. So for the purpose, we have taken a GitHub Actions pipeline so that your cluster can be scanned and scheduled automatically, right? So getting the results as CSV and visualizing those results in Grafana for the reporting as a reporting solution. So that's what basically the idea. And also, like, we have created this as a pre-built Docker image so that you don't need to install these tools each and every time you run your GitHub Actions pipeline or any other CA tool for that purpose. And then like another important thing is like, we are not installing anything inside the cluster, right? We are keeping everything outside so that, the team and people will have confidence using this solution. So probably, yeah, you can try this on your own, like, you can use your own security tool and probably like try this on your own. And hope this use case is like really useful.